Okay, so we're talking about solving linear equations, and linear inequalities are kind of like equations, and they solve the same way. I'm just solving this one here, and so far I haven't multiplied or divided by a negative, and so I'm fine. I'm going to now subtract 7 from both sides. 3x greater than or equal to negative 15, and then I divide by 3 on both sides. I never had to switch the sign. Did you guys get x is greater than or equal to negative 5? Okay, good. Do you know how to graph that, though? Okay. Let me make sure. Make a quick sketch off to the side of your paper. What you think the graph of that would look like. And I think some of you are going to draw your line the wrong direction. I'll find out which of you do it right and which of you do it wrong. So my first goal would be to make sure you start at x is negative 5. X is negative 5 right about there, maybe. Depends on how you number it. And then the only question is, should I go left, right, or should I go up, down for the line? What do you think? Up, down. Because if I say x is negative 5 and then I start going this way, do you get how that's not x is negative 5 anymore? That's where x is like negative 4. So I can't go that way. I got to go this way. That's another spot where x is negative 5. So is that, that. It's like that. And then, should it be a solid line or a dotted line? Solid. If it's got one of these, it's a solid line. And then, should it be shaded to the right or to the left? Right. To the right, because it says greater than, and we all know the things that go that way are greater, and therefore we shade this way. Now, I don't expect you to do any more than what I just did there. Just like a few lines. You don't have to make this like totally shaded in. The reason? I know where we're going with this. When we're all done with these, we're going to have graphs that have like 5 equations, like shade this way for that one, and then draw another line this way and shade this way for that one. And it's actually a lot better if you don't shade the whole graph in, otherwise by the 3rd or 4th line you draw, you can't even tell like what's been shaded and what hasn't because it's all so super dark. But now you can tell these all kind of converge in here, and that's the only place you make super dark. All right, so you can just do a little shading on one side of the line. That's good enough. It saves you time, too. All right. Let's move to the next one. Take a look at this one. Graphing linear inequalities. Y is greater than or equal to 2x minus 3. Would you quick make a sketch of this? See if you can do it quick. You know, put the line on there. Shade one side of it. I don't expect you to be perfect, but give it a shot. Some of you that don't even know how to start at the y-intercept, which is negative 3. And then, what's this thing? The 2, what's that? So I'm going to put it 2 over 1, and that'll remind me it's rise over run. Rises 2, runs 1. Rises 2, runs 1. Rises 2, runs 1. Rises 2, runs 1. And then I have a solid line because it's got an or equal to. That thing right there tells me to use a solid line. And then should I shade above it or below it? Above it. So just a little shading like this would be fine. Raise your hand if you were in the doing it the right way. Okay, good. Yes, sir. Ah, okay. When the line is like this, it's easy to tell what's above or what's below it, right? And if you're above or below it, that's just greater is above and less than's below. But you're right, the one situation where we can't do above or below is if the line's straight up and down. If it's straight up and down, you can't do above it or below it. You got to go right or left. But this one actually makes sense too. If I want to be greater than this line, greater than are numbers that are over this way, right? So I shade to the right if it's greater than. Okay, but if it's a line that goes across in any way, including all the way across, like straight across this way, then you can either shade it above or below it. You get what I'm saying? It's always either above or below. Okay. Okay. Try again. Ask me a quite different question, or same question in a different way. Gotcha. I think I get your question now. So, like, what if on the next question it looks like this? Then would you know which way to shade it? No, you wouldn't. Because, yes, you have to have it solved for y. You always have to have the y on the left side. Now, I know you're saying, okay, y is bigger than x. Why couldn't we be talking about x is bigger than y? The only reason we're so stuck on y always being on the left-hand side is just, it's like tradition. Could we solve everything for x? Yeah, we could. But usually we solve things for y. One of the main reasons is, if you're going to put it in the calculator only has a y equals screen. You know what I mean? Doesn't have an x equals screen. So yeah, you're going to always solve these things for y. So yes, it'll always have the y be on the left, and it'll always be dependent on the y, not the x, whether which one's bigger than which one. You always just start with that y on that side. Because any two numbers, you could say 5 is greater than 3. Well, why aren't we saying 3 is less than 5? Either way is true. Either way works. But we just always have the y on the left side because it's more handy for graphing. Okay, so hopefully you would be able to handle this one where it was -3, slope like that, it was greater than, so I go above it. Okay, those are easy, right? What if they're like this? You just got to solve them for y. Once you solve it for y, it's like super easy again. This one's a little complicated because it's got a fraction in it though, so let me make sure you get how to do this one. So I'm going to subtract 3x from both sides, and I'd have -4y is less than or equal to -3x plus 12. Yeah, I could have wrote that backwards like this, but I like having the x there because then it'll look like the slope when the time comes. Next one's divide by a negative. Oop, that should ring alarm bells. When I divide by a negative, what happens? Switch the sign. Y is greater than or equal to +3/4 x minus 3. So then I start at -3 again. And this one has a slope that's already a fraction. It's actually a little easier in a way because it divides itself into rise and run. The rise is 3, run is 4. Put a dot. Rise 3, run 4. Put a dot. And then is this a solid line? Yep, because it's got one of these. So it's solid. And then is it above it or below it? Above it. This is greater than. Okay. Raise your hand if you were doing that kind right. Okay, good. Yes, in the back. Nope. I did not switch the sign for subtracting 3x because that's not multiplying or dividing by a negative. I switched the sign when I did this. See, that was dividing by -4. This is adding or subtracting a negative, and that's okay. It's only if you multiply or divide. I was dividing by -4. That's when I switched the sign. See, it went from a less than to a greater than. Okay? All right, moving on. And those are really good questions. And questions do not mean that you're dumb. Question means that you are following with me, which means I know you're actually with me, and that's a really good thing. And it also means you care. You want to know how to do it. So please, feel free to ask those questions. All right, so this, substitution. You haven't done this in a while. Would you try this one with me? Substitution is a really crucial thing to know how to do. It really does come up a lot in math. All the time you're swapping out one thing for another thing. You're substituting it in. Say, instead of this 50 cents here, I'm going to use a half because it's a half a dollar. Or instead of these 2 squares that go side by side, I'm going to use a rectangle. It's the same thing. You can swap them out. All right. So if I say x is 2y, then if I look at this equation, if I know x is 2y, right, instead of this x right here, I can put a 2y. And why is that good? Because now I only have y's in my equation, and I can solve it really easy. You got what I just did there? I took this little fact that x is 2y, and then right here where the x is, I put a 2y. And then I have 2y minus 3y, which would make -y equals 14. That's one of my favorites. Because then the easiest thing you can do is just say, if -y is 14, y is -14. It makes sense to me. If it doesn't work for you, you got to just think, I got to multiply everything by -1. That doesn't just come naturally for you. All right, am I done when I have y is -14? No, because I have an x and a y. So then I have to figure out x. So I take this negative 14, I stick it anywhere I want to, and I'd say the easiest place is right there. If I put a negative 14 there, I'll know that x must equal 2, x equals 2 times negative 14, and that would be x equals negative 28. My final answer is negative 28, comma, negative 14. You usually put your answer that way because it shows that this is x and that this is y. Could you write them this way? Sure. Either way is okay. All right. Now, using elimination. This way is one of my favorite ways to solve things, and I need you to understand why. I used to just show people how to do it, and then I realized you can handle this. You can handle why this works. Okay, if I just look at that top equation, 2x plus y equals negative 2. Do you get that I have the option of adding 2 to both sides if I want to? Isn't that okay if I do that? Yeah, I can add 2 to both sides. It won't help anything, but I can do it. Could I subtract y from both sides? Isn't that okay? So you can add or subtract anything you want, as long as you do it to both sides. All right. So, if I add these two together, why can I add this to this side and that to the other side? If I'm adding straight down here, I'm adding negative 2 and negative 6 makes negative 8. How come I can do that? True. But here's the thing. Here's what I'm trying to say. Just look at that. Do you get I added negative 6 to that side? Don't I have to add negative 6 to this side then? Yeah. I'm supposed to add a negative 6 right here. How come I can add that other stuff instead? Yes? Because it's equal to negative 6. It's exactly the same thing as negative 6. You get that? If I added negative 6 to both sides, I could do that. But since this other stuff here, right here, is equal to negative 6, that's why I can add it to that to the one side and the other to the other side, because they're equal to each other. So over here, I'm going to add 2x and 5x makes 7x. And y and 2y makes 3y. And negative 2 and negative 6 makes negative 8. I can do that. The only problem is nothing canceled. It's a true statement. What I made is true, but nothing canceled. But now, watch the smarter way. Does anybody know what I'm going to do here? Because you've done this before? Ah, in the back row. You're correct. If I multiply everything by negative 2 on that top one, negative 2 here, and times by negative 2 there, then this one will cancel this one when I add them together. You get that? Negative 2y will cancel positive 2y. Why is that good? Because now I'm only left with x's. So what's negative 2 times 2x? Negative 4x plus the 5x makes x. These guys cancel. Negative 2 times negative 2 makes positive 4. Positive 4 and negative 6 makes negative 2. And look at that. I solved it. And once you've got that, you could do elimination to find the other variable too, but it'd be way harder. So just take the x is negative 2, stick it in anywhere you want to solve for y. So if x is negative 2, I'm going to put it right there. And so I'm going to have negative 4 plus y equals negative 2. Add 4 to both sides, y equals 2. So I got negative 2 comma 2 for my final answer. All right, that's called substitution and elimination. I went kind of fast because I assumed that you'd learned it last year. And some of you have and some of you haven't. So some of you might need a little help on the tests or on the homework on this, and that's okay. I'm willing to help you with that. So I'm stopping here so that you can have a lot of time to work on your homework. I want to show you which one your homework is. For my classes, if you're listening to the video at home, you might actually be assigned both of these. But for my classes, I am only going to have you go to assignments. And under assignments, there's this big long one here under 919. Linear Inequalities in Systems of Equations Review and Investigation of Parent Functions worksheet. That huge thing. Go in there, and there's two worksheets that a lot of these are like extra copies. Some of them are in Word, some are in PDFs. One's the key. All we really need to do, actually two of them are keys, the bottom two are keys, is the fourth one down. Go to the fourth one down. That's the one I want you guys to do for today. I'll say open. That is your homework for today, right there. All right, and this basically just solve these, get them down. The first ones are only x's, so it's really simple. Just solve those equations. And if you ever multiply or divide by a negative, make sure you switch the sign. In the next part of the assignment, it's graphing them, and just be sure as you're graphing them that you use a solid or a dotted line, and make sure you shade on the right side. And then the last kind are those substitution elimination ones that we talked about. All right. I'm going to just take 2 seconds and talk briefly about parent functions because I know some kids are assigned that today in their classes. Let me just take 2 seconds and explain it to you. I think you'll get it. You know, you've seen parabolas before, haven't you? They go like that. But have you seen square root function before? Okay, get used to it. It's a parabola on its side. And 4 as a square root of 2. Do you see how it sort of looks like a parabola except on its side, but without the bottom part? Okay, that's what the square root function looks like. The next one's the absolute value function. If you stick a 1 in here, you'd have a 1 goes with 1. If you stick in a 2, absolute value of 2 is 2. It's really simple. Absolute value of 0 is 0. But what's the absolute value of negative 1? 1. What's the absolute value of negative 2? See how it makes a V shape? Instead of a parabola U shape, this is a V shape. All right. And then they're going to ask about domain and range. I'll explain more about that tomorrow, but do you remember which, I told you this was important, which one goes with X? Domain or range, which one goes with X? Domain is X, okay? So this is about the domain of this, and I'll explain more about that tomorrow. For today, I need to get through those tests and getting some scores from you and stuff, so we'll talk more about domain and range tomorrow. And that's it for today.